Hello and welcome back. Higher Maths, Logs and Exponentials. Today, applications of exponentials and logarithms, which I think is lesson 7. Let's go straight into an example. So we have some breeding gulls in a nature reserve, and the population of those gulls is given by this equation. T is the time in years. How many pairs were there initially? Part B, when will the population exceed 2,000? Okay, so initially the time is 0, so I'm just going to substitute in 0, so 500 bracket 1.09 to the power 0, so I'm only raising the 1.09 to the 0 there. So 500 multiplied by 1, which is 500 pairs. So initially there were 500 pairs of gulls. Part B, when does the population exceed 2,000? So population, P of t, is 2,000 here. So 2,000 equals 500, 1.09 to the power t. Let's make that a little bit clearer. Oh, sorry. So 2,000 divided by 500, so 1.09 to the power t will equal 4. Move from exponential format into logarithmic format. So log of 1.09, log to the base 1.09 of 4 equals t. So calculate a time, guys. Log to the base 1.09 of 4. 16.086 years, so it'll be 17 years before the population doubles. Assuming the question's asking for whole years, it's not 100% clear, so we could leave that as 16.09 years or 16.1 years, because it wasn't asked for in the question. I think that would be okay to leave it in any three of those answers that I've just mentioned. So I've just gone for 17 years, and then in a bracket, assuming whole years, I've just put, so just to show whoever's looking at my work that I have thought about it. Okay. Similar example. So we have some radioactive nuclei here. The number of nuclei is given by nt, so the number after t years equals n0, the initial amount, e to the negative 0.05 t. Okay, so as always, we're given a formula. Find the number remaining after 50 years. So we're told the time's 50, so we'd substitute 50 for t. So n of 50, the number after 50 years, just get the notation right from the start. 500 e to the negative 0.05 multiplied by 50, type it all into the calculator, 41 nuclei. Part B, the half-life of a radioactive sample is defined as the time taken for the activity to be reduced by half. Calculate the half-life of this sample. So if n0 is our initial amount, what would half of that be? That would just be half n0. Okay. If you don't like that idea, find out what there is initially, so substitute 0 in to our original equation. So, and we'd find out that there's 500 nuclei originally, and just work out half of that, which would be 250. Okay. But I prefer to see this, but if need be, if you're not happy with this idea, I know it does catch one or two people out and they're never really that comfortable with it. Just find out the initial amount and half it. Okay, so here, next step, I want to make e to the negative 0.05 t the subject of the formula, so I'm going to divide through by n0, so they'll cancel, dividing both sides by n0. Well, here, 250 divided by 500 is 1/2. So either way, we're going to end up with this next, guys. So I've got e to the power of something, so I'm going to take log to the base e, or rearrange from exponential format into logarithmic format. So log of a half, log to the base e of 1/2 equals negative 0.05t. Divide through by negative 0.05 to make t the subject. So log of 1/2, log of 0.5 divided by negative 0.05. There we go. Just remember guys, log to the base e has its own special button on the calculator. It's a natural logarithm button, it's the ln button. So ln 0.5 there. Okay. Right, so if you need to re-watch that bit, just rewind the video back 2 minutes guys, just watch it again if there's one line that you're not quite sure about. It was basically exactly the same as this one but with different numbers. So once you're happy with that, have a go at page 16, exercise 1H, question 1 to 5. Exercise 1I is really extension work, 1, 2 and 4. Have a go at those if you're comfortable with 1 and 5. Okay.